Welcome back to Think Thrice Problem Solving. Today we're going to be solving a problem that I'm really excited about. So we have this limit as n approaches infinity of n factorial over n to the n raised to the 1 over nth power. All right, so let's try to figure out what this thing approaches. So if you want to give it a shot, go ahead and pause the video. Otherwise, we're going to jump straight into a solution. And my hint is integration if you're going to pause the video. All right, so let's go ahead and look at this thing. So the first thing we're going to do is we're looking at this, and we notice that we have n's in here, and we also have this 1 over n, which makes things a little bit messy. So let's go ahead, and since n is positive, n to the n is positive, 1 over n to the positive, let's take the natural log. So let's, getting ahead of myself. So let's call this thing L. And let's take the natural log of L, which is then going to be the limit as n approaches infinity of the natural log of n factorial over n to the 1 over n. Okay, using our log rules. So the reason we did that is so that we can pull this guy out. So this is going to end up being the limit as n approaches infinity of 1 over n times the natural log of n factorial over n to the n. Okay, so let's look at the inside now. So this thing is still pretty ugly in here, but we notice that we have some things going on that might be interesting. So this n to the n and this n factorial, let's see what those guys look like if we break them up. So let's rewrite this as the limit as n approaches infinity of 1 over n times the natural log of, this is going to be 1 times 2 times 3 times 4 all the way up to n. And then this is going to be divided by n times n times n times n all the way up to n. So using my log rules again, since the log of products is equal to the sum of logs, I could look at each individual product here, and I could break all these up into new equations. So let's go ahead and do that. So if I do that, I have the natural log of L still, so just remember what we're doing, and this is going to be the limit as n approaches infinity of 1 over n times, so it's going to be the natural log of 1 over n plus the natural log of 2 over n plus the natural log of 3 over n all the way up to the natural log of n over n. All right, so this is where that little hint comes in. So my hint is integration. And this is where we're potentially going to be looking at it. So go ahead and pause the video if you want to noodle over this for a second. And let's think about how we can relate this to integration. All right, so I gave you the hint of integration. So let's try to remember again what integration is. So how did we initially define integration? So when we initially defined integration, we talked about what's called a Riemann sum. And we said that the integral from a to b of f of x dx was equal to the limit as delta x approaches 0 of the sum of I equals 1 to n of f of x sub I star times delta xi. So essentially what we're saying is the size of every single delta x goes down to 0 across our entire domain. And what did this look like? So essentially when we did this, what we're really doing is we're looking at a plot, and we have some function. So let's say we have some function that looks like this. And I'm taking these rectangles, and I'm saying I'm going to take this. So this is my delta x. That's my distance in the x direction. And then my height of my function is my f of x star, xi star, where xi is somewhere within the bounds of that rectangle. Doesn't matter specifically where because we're approaching 0. So then I'm going to take another rectangle, and now I'm choosing my next. So once again, this is delta x, and then this is my height, f of that x star. And then I'm doing the same thing again, and we're taking this delta x, and we're multiplying it by the height of my function. So hopefully this is starting to look a little bit ordered in the way we're doing things. So what's the limit as n approaches infinity of 1 over n? So the limit as n approaches infinity of 1 over n is 0. So if 1 over n is treated as delta x, then essentially what we have with this equation is the limit as delta x approaches 0 of delta x times the natural log of delta x plus the natural log of 2 delta x, and so on. So what's happening here is I'm looking at delta x, which is inside my first rectangle. Then I'm looking at my function evaluated at 2 delta x, which is in my second rectangle. And then I'm just adding delta x every single time. So I'm essentially evaluating this function natural log inside one of these rectangles. So you guessed it. So hopefully this is all coming together and you're seeing what we're doing here. So this is actually exactly what we're doing here. But f of x is the natural log of x. And what are our bounds? Well, we're starting at 1 over n. So we're starting at an infinitely small number, and we're going up until we hit n over n, which is 1. So what this whole problem is going to boil down to is the natural log of L is equal to the integral from 0 to the positive side to 1 of ln of x dx. All right, and this is actually our whole problem now. So what we've done is we've taken this kind of crazy looking guy up here, so our big limit, and we've said that this limit is actually, or the natural log of that limit, is this integral right here. So now, in case you haven't done this in a while, we can find the answer for this integral. So let's go ahead and do that. So this is going to be, let's treat u as the natural log of x. So du is 1 over x. dv is dx. So v is x. You need some integration by parts. So we get that the ln of L is going to be equal to x ln of x minus the integral from 0 to 1 of 1 over x times x, which is just 1 dx. So that's going to give us x ln of x minus x evaluated from 0 to 1, and this is evaluated from 0 to 1 as well. Okay, so what does this give us? Well, what is the, so remember this is 0 from the positive side, so ln of 1 is just 0, so this is going to equal 0 minus the limit as x approaches 0 from the right of x ln of x, and this is going to be minus 1, because this whole thing evaluates to just the number 1. So our question is, what is this? We can use, so if we look at this, ln of x as x approaches 0 is negative infinity. ln of x is 0, but we can rewrite this. So let's look at this term here. So the limit as x approaches 0 of ln of x over 1 over x. Now we have a value approaching infinity over a value approaching infinity. So we're going to use L'Hopital's rule. So what do? We take the derivative of the top and bottom. So we're going to have the limit as x approaches 0 of 1 over x divided by negative 1 over x squared, which is going to be the limit as x approaches infinity, or 0, sorry, of negative x over 1, which is going to be 0. So what we got here is that ln of L is equal to -1. So if ln of L equals -1, that means that if we take e raised to that guy and e raised to that guy, now we have L is equal to 1 over e. And it turns out that that is going to be our final answer. So this one was a lot of fun. So we got to do a few different different solution techniques. So first we got to work with natural logs to try to simplify our problem a little bit. Then we saw a pattern, and we were able to connect that to our old Riemann sum definition of integration. Then we got to solve the integral of the ln of x, which we had to use a little bit of extra calculus and limits, including L'Hopital's rule, and that got us to our final answer. So if you enjoyed this video, please like and subscribe. If you have your own video idea, please send it to thinkthriceproblemsolving@gmail.com. And as you're working through problems on your own, think once, think twice, and if you really get stuck, think thrice.